So today we continue what we did last time, and last time we had this simple drawing on the canvas with a few houses and a tree. And I already copied this to lecture 3, what is today, and I entered here that what we are gonna do um, today is this animating on the canvas. So I will teach you how to make things move on the canvas. And we agreed last time that it's going to be some kind of moving animation, like something like we are in a train and we see the objects moving to one side of the screen. Before we start here, I need to remind you what we have here. And actually, I want to explain things a little bit better because last time I got some questions after the course, after the lecture, and I want to address these to everybody in case you don't understand why I did something and why I didn't. Do ask questions when you don't understand something. So this is very, very important because usually in class I can figure out if you have some issues. I just look around and I see your eyes like, are you focusing? Is your face like this? Or is your face like this? And I can figure out that something is wrong and I have to repeat or explain in a different way. But now I don't see anybody. And even if you turn on your webcams in Teams, I'm not gonna be able to look there, toggle all the time and type code. So do ask if something is unclear and I will explain again. Now, we have this simple setup here. And one thing that was a bit unclear was this canvas size. So I'm setting here the size of 1000 pixels. And it seems like if I'm putting here 500 pixels instead, and I'm going to refresh this page, not much is different. The screen still looks the same. Houses are a bit different because of the randomness, but what gives? What is this size here, and why is it not affecting the canvas? Well, the reason is that in the CSS file, I'm actually scaling the canvas to be 80% of the minimum between the width and the heights of the browser. If I remove this code here and I refresh the page, you will actually see the canvas in its true size. And I even need to scroll the screen a little bit. If I'm going to go back to main.js and make it now 100 pixels, and I go back here, you can see that it's a very small 100 pixel canvas. But if I re-enable this stretching in CSS, which allows me to make applications that are full screen or that resize with your device, then I will still see it as 80% of the minimum between the two values. And now you also see these bad artifacts because I'm actually stretching a very, very small image to fit on my bigger screen here. So this is raster format. When you are drawing on the canvas, the math that you are doing, the vector shapes that you are thinking about drawing, they do become pixels. Okay, but yeah, and the same thing goes opposite as well. So if I disable now the stretching and I put a very, very big canvas size, like 1000 pixels here, my canvas now is really big and I have to scroll horizontally and vertically if I want to see this. I can't even see all of it at the moment. You may want to have a bigger canvas. Who knows, maybe you want to design some image that will be printed on the size of a building. You want a very, very big image. But you still want to be able to see it on your screen. So I'm now stretching this very, very big image, squishing it to fit and to have it visible. So these are the reasons why I am teaching you these techniques. I don't know which will be useful for you, but I think some of them will. Right, and another thing that was quite confusing to many people were those scale, translate, rotate, whatever functions. So they are indeed a little bit more than what you need to draw on the canvas. So you can draw things without those methods whatsoever. But if you do use those methods, then you can keep things here very simple and work just with percentages. Okay, side note, it's not really a good idea to have here these hard-coded values all the time. I don't know what they mean, and I would need to write comments about those or something else. In my case, it is okay because I showed you this kind of diagram previously, which actually changed. Our house now looks something like this. I made a new diagram. And the values that you see in my diagram here do appear in the function code. So you can see my diagram, you can consider it as a documentation of the code. Even better would be to serialize these objects in JSON format or in some kind of format that is human readable and computer readable as well. So then you have something really, really nice. But I'm not gonna be so harsh with you guys. So yeah, I redefined my house according to what we experimented in class, and it looks like this. It has a different number of levels, and each of them has a random angle at the moment, and each level is 10% in height and covers the whole width. The roof there has some 40% of this size. And I also made a small documentation about the tree, which I changed a little bit from last time because I was tired and I got some of these percentages wrong. So you can check the new code and see that it's a little bit different, but it looks pretty much the same. So documenting these is really important. It tells the full story of what the code is doing in the case of these hard-coded values here. Yeah. Okay. And it simplifies the code if you use scale, translate, rotate, and you don't need to do this thing that you see here. So here I am drawing a house and I'm scaling this house from 85%. I'm scaling it to the size of the full canvas. I could actually remove all of these values here. So my code can become much cleaner if I do scale in the beginning. And this is not just cleaning up the code, but it's also making it more difficult to have bugs in it. Because maybe you have a typo in one of these variable names, or maybe, I don't know, many things can happen. Like you forget to multiply, you put add instead, and then you're wondering what is wrong here. So usually cleaning up the code and making it as easy to understand as possible is a good idea. And these scale, translate, and rotate, you don't have to use them in any of your projects, but I do recommend them because they make some things much easier to work with. And here, this is the maximum value, so 100% or 1. And let's see, do I have any more things like this to fix? I think no. So let's see if the code is equivalent. Now I'm going to save the file, refresh the page. Yeah, and everything looks the same, but I don't multiply those things everywhere. And if you consider translating, scaling, rotating, those lines are going to be very long that don't even fit in your screen. You're thinking, what is really happening here? So my scale in the beginning basically made the one small pixel in the top left corner stretch all over the canvas. And now I'm drawing in that one small pixel that is actually stretched. And that's somehow how you can imagine here. So I just have a one pixel to work with, but when it's stretched, you get the resolution back. So anyway, do play with these and try to learn them. They are very, very useful tools. But yeah, let's continue with what we should do today. And first thing I'm gonna do is disable this overlay for now, because I don't want to close it every time. Of course. Actually, no. So every time okay, don't quote me on this. I think I'm correct, but I'm not really an expert with these things either. What I think happens is that if you have multiple saves, like what happens now, it saves like multiple copies in a stack. And when you call this restore function, it just restores to the previous saved thing that you did. So I'm almost sure about it that it works like that. So basically, if you only save at the beginning or don't save at all, then yes, this and you translate many times, then that restore is going to get you back to at the beginning. But if you move something, save, move something, save, then when you restore, I think it goes back to the previous saved method. I'm not 100% sure. But yeah, that's somehow how it works. Here I don't need to restore anymore because I'm not doing anything with the canvas after I'm drawing these houses. So I don't care if it's still stretched. Yeah, you're welcome. Okay, so what do we do today? We do the animation, right? Well, to animate things on the canvas, in HTML in general, you can use several methods. For example, you can use a function called setInterval. So this is a function that expects a callback function what to do in the interval. For example, draw scene is going to be our callback function, and I'm going to say do it every 100 milliseconds. If I try now to yeah, okay, my draw scene is doing some initializing here. I don't want these to happen on every frame. Let me move this here. Okay, we are getting some error. I don't need to initialize them with the size and the scale, but I do still need access to the context. So that's what this error is here for. So what you see now is actually the scene being redrawn 100 times, once every 100 milliseconds. And it looks like this. Now, it looks like that because my houses are a little bit, have a little bit random properties. And it kind of looks like they jiggle a bit, which is kind of nice effect to have here. But today we will do something different. Now, this is one way of doing this, this animation. There is another way to do this animation using another function called setTimeout. So this setTimeout function will not repeat something multiple times, but it will make something appear after a certain time. And usually this set timeout function is called recursively. You can try it. I'm not going to spend time with that if you want to experiment, because both of these set interval and set timeout methods are a bit obsolete nowadays. There is a better method that everybody is using to animate, and I'm going to teach you that one. The method that I'm going to use is called request animation frame. And I'm going to make a function here called animate. And inside this function, I'm going to call window request animation frame and pass this same function as a parameter. So basically what happens is that it's being called recursively as soon as the previous frame has finished processing. This is going to be kind of the same thing as the set interval. So it calls something one after the other. So the content in this is going to be this draw scene. And then it's going to request another animation frame, and it's going to redraw the scene again and again and again. The difference is that these set interval and set timeout methods, if you try them, you will see some kind of uneven spacing between frames. Like it could be that sometimes it waits 100 milliseconds, but even if you specify it here, maybe sometimes it's just 50 milliseconds or 150. It's somehow inconsistent. And this request animation frame method, it's more reliable and it looks more smooth. So everybody is recommending that you use this nowadays. So let's see what we get here. Nothing, because I am not calling my animate function anywhere. So I need to call it first to start. Okay, it's a bit faster because my processor is maybe better and can process more than 10 frames per second, like what I had previously here. But you get the same result as before. So I recommend you stick with this one. Sometimes if you really want a specific frame rate, then you could try using one of these methods as well. It doesn't really matter, it's just a few lines of code that you need to modify. Okay, so that's the animation. Thanks for watching. See you next time. Kidding. So of course things are animating now, but we said that we are going to make the landscape move and maybe add more items as we are moving. So houses are going to be added on the right, and let's have them move towards the left, somehow illustrating that the train is moving towards the right. Now, the problem with that is that these houses are jiggling. I don't want my house to jiggle like this. This is something a little bit funny, but it's going to be disturbing. So I'm going to teach you a little bit about object-oriented programming, because I want the house to remember its state. I want it to remember how tall it is, how many levels there are, the color of its roof, if it's a door or not, and even the angles of the beams that are building the house. So in object-oriented programming, you define a class, and this class is going to encapsulate these properties. Then we're going to define a draw method in this house class that just draws it with whatever properties are inside it. So the house will remember all its properties, the paint on the roof, the height, and things like that. And on every frame, when we need to draw it moving, it will draw the same properties again, not some regenerated random stuff that you see here. So let's see how we do this modification. Just a second. Yeah, okay, Tony is confirming that that is how it works. I think it is like that, almost 100% sure. Okay, so our draw house is going to become an object. I'm going to create here a class house, and a class has a constructor. And to define constructor in JavaScript, you say, I think like that, maybe. And our house will have similar properties as before. This location where I'm going to show it, the scale, how big it is, and other kind of properties like the wall color and levels and things like that. So what I'm going to do is I'm going to take these properties from here and store them as part of this house object. So this location is equal to location attribute that I'm passing here. I'm storing it inside this thing here. Okay, maybe I rename these so you don't get confused about this this notation. That's just fine. So now the house knows its location, its scale, and its properties. And I'm going to have a method here called draw that it's gonna draw the house on a given context. So basically, I'm gonna copy this code pretty much from here, and I don't need the draw house function, and I'm going to paste it inside my draw method of the house object. Here, I can't access things like location without specifying this in front of it, because it means that we are referring to the location attribute of this house object. So location is one of the places where I have modified this. Let's see if this appears. It appears also here. Yeah, I mentioned it too fast, but we will have some, we have a completely different animation. Okay. So my screen is lagging. That's quite bad. It could be. So it's quite processor intensive to animate this, and I think it's using as much as many resources as possible. I will disable the screen while I type the code, and maybe now you can hear me better. Okay, so this needs to be in front of location and all the other things as well, like the scale and the properties. So let's take the scale here. Otherwise, it will say that these are variables that have not been defined. And the properties. Again, I'm storing them as part of the object here, and I'm retrieving the attribute, the locally stored attribute. Okay, yeah, thank you. So good that you hear me at least. I hope the video is better now. Okay, so we have a new object, a house that stores its properties, and we have a method to draw this house, and I think that we are ready to try it. So in our draw scene function here, I'm drawing a house, another house, another house, but I don't want to create new houses on every scene, at least not just yet. So I want first to create the houses. Maybe I store them in an array. And then here in the draw scene, I just iterate through all the houses and draw each of them. So let's define the houses here for now. I'm going to use a global variable houses, and it's going to be an empty array. And I'm going to add to this array a new house. And the properties of this new house are going to be exactly these that I have used previously. So this is one house, and this is another house. And this is the final house. Right, but my properties also need to be there. So the first house properties here, and the last house properties are a little bit different here. Okay. I will cancel this animate function a little bit and just refresh the page to see if I'm getting any errors right now. Okay. Draw house is not defined. Yes, because I will not need these anymore. Let me just comment them out a little bit. Okay, no more errors. And here in the console, if I'm going to log houses, I will see that I have 3 house objects. And each of these house objects has a location and a wall color, a roof color. So you can use this console from the browser to inspect even objects that you create yourself, even these kind of structures that you create yourself in the code. And it's a very, very useful tool here. So we have the houses, they are there, but they are not displayed anywhere. So my draw scene function here is going to loop through the houses, and it's going to say for each of the house to draw it on the context. So now I'm only drawing the houses have been there all the time, and this should work. So they are back there again, and I can now activate my animate function here. And when I refresh, you can actually still see them moving because I didn't record how offset are the levels. So they are still being generated randomly here in the draw function. So you can see at every frame when I'm drawing, I'm making it jiggle a little bit. So that also, these angles also need to be a part of the house blueprint. It's a mistake that the house was built with and it lives with. But you can see that it is a little different anyway because the roofs don't change color randomly anymore, the ones in the back. They do if I refresh the page because that's when the blueprint of the house is defined, but not anymore at every frame like it was previously. So let me now close this tab and just work like this for a while so that my video is clearer when you talk to me and when I speak, and fix this issue. So I want here to define angles for each of these levels that are that the house came with. And when I display the house, I don't want to rotate randomly. I want to rotate in a meaningful way. So I mean, not in a meaningful way, but using the stored angles of the house blueprint. So this is going to be an empty array, which I populate based on the levels here. So let me just copy this so I speed up writing. And I'm going to say angles of I is equal to a random angle. So I still keep randomness when I create the house, but not when I draw the house. So my angle when I draw the house here, it's not going to be random anymore. It's going to be the value that was calculated when the house was constructed, if you will. So let's see what happens now. Okay. Yeah, indeed, it lags on my computer because I'm recording and also talking to you guys at the same time. It seems like my processor is actually very close to 100%. But yeah, no more jiggling. And now you might think like, what all this effort, and it looks like in the beginning before the animation was added. But bear with me. Now the fun things will start. So let me do this same thing again. And now I'm going to make the houses move in a very simple way. So here where before I'm drawing the scene, I will say that I want to iterate through all the houses. And I will make each house's location the first component. So location of 0 is the x-axis. Decrease by 1. And let's see what happens now when I refresh the page. Okay, nothing. My console doesn't show anything. Okay, change of plans. This, yeah. Okay, change of plans. This animation technique is recommended and it does work, but I'm gonna use set interval because it's not gonna disrupt my video with you guys. So disabling this now, and I'm going to re-enable set interval with animate function here, and I will remove request animation frame. Very good, very good. So remember that we are now in the 0, 1 pixel size. We did this scaling in the beginning of the code. So we resized everything to be referenced with percentages in the 0, 1 space. So if I modify by 1, it's gonna immediately jump 1 canvas size to the left, and I'm not gonna see any kind of movement here at all. But anyway, I did change this set interval here because I think it's gonna allow me to talk better and it's not gonna lag my computer so much. So it's really the same thing as previously. Both of these methods are going to work. The request animation frame will be a little bit faster because it just refreshes whenever it can refresh, so as soon as possible. And set interval here is going to refresh every 100 milliseconds. But it doesn't matter. I will stick with set interval just to because it's easier to talk to you guys. Okay, great. So houses are moving. Yes, great. They are moving, but I would like maybe some things to happen here. Maybe I want more houses to come from the right side of the screen. And this movement doesn't really seem natural, does it? Because in the real world, when you go outside and you are in a car or in a train and you look at the screen, you will see that the things in the background appear to move slower than the things in the foreground. So this is something called parallax. I'm going to link some video here that is where I teach something about parallax, but maybe it's not that, let's see. It's not that important, but basically it means that objects in the background appear to move slower than those in the foreground. And I'm going to simulate this by moving the house based on its, at a different speed based on its y coordinate. So let's see if that makes any sense, because if it's higher drawn, then it's going to be more towards the background in my space here. So let's try this. Instead of saying here minus 0.01, the speed is going to be multiplied, by the house's y coordinate. So the location of 1 here. Let's see if this makes any change. You can actually see something is happening. The distance between these two houses gradually gets bigger and bigger and bigger. So in a sense, it is something that we expect to see here. Of course, some things here are hard to model exactly, and if you really want a 3D perspective, you need to read about some formulas there. I'm not going to be so precise today, and something like this is just fine. So now I'm going to add more houses that are coming, new houses that are coming from the right side of the screen. Let's see how that one works. In my animate function, I'm going to also say houses, push a new house, and let's see what properties we have used in the past. So, okay, I just copied this house. It's gonna be a brown house with 4 levels and a random roof color appearing, well, let's just leave it like this and see what happens. It's easier to learn in this way. So something weird happens, right? A new house is being added into the scene at the exact same location, but with a little bit different properties because of the randomness that I have the house blueprint incorporate in it. I don't want the houses to come so frequently. This is way too much. And I want the house to appear off screen, not just instantaneously appear in the middle of the screen somewhere. So instead of appearing 85% at 85% of the screen, I'm going to say appear at 1.5, for example. So this is going to be off screen by half a screen. That's where the house is going to be generated. And I'm not going to generate this house on every frame. This is way too many houses here. I'm going to say if probability is less than 10%, make this house. And probability is going to be a random value. So at each frame, I'm gonna have a 10% probability to generate a house or not. And this is going to make things a little bit different, I hope. So because the house has generated quite much off screen to the right, it takes some time for it to come into the screen. And now you see the houses appearing. Yeah, they are appearing at the same vertical axis and vertical axis location, and at different kind of intervals. Some of them are closer to each other, some of them are farther from each other. So this is random here. There is a randomness here. Whenever this random value is below 0.1, so random is usually between 0 and 1, like this. But if it's below 0.1, so in 10% of the cases, then it generates the house. Maybe this is a little bit too much, and I'm gonna put here 0.2 and see what happens. So I'm getting just way too many houses here. Now, what I'm gonna do next, I'm gonna restructure this code so that it's easier to read. The first thing is this. What is this 0.1 times houses location? So this is a hard-coded value here that has a purpose. It's going to control the, has a meaning. It's going to control the speed of the train, basically. Yes, it's going to be scaled based on the houses in the back and the houses in the front, but the ones in front of you are basically moving at the same speed as your train. So I'm going to say here speed, and I will just export it as a global variable. Let's make it 0.02, a bit faster movement. I don't want to wait so long for the train to get there. And yeah, so my houses here are generating on the right side, but they are all at the same vertical location. So I want this to be random as well. I'm going to say here y is equal to, instead of this 0.6, it's going to be a random value. So now it can be anything from the bottom to the top of the screen. So that means maybe a little bit too much, because it's going to generate houses in the sky as well. But let's just learn step by step what happens. So I'm going to replace here the y coordinate to be random, and let's see what we get. So houses are moving now twice as fast as previously, and you can see a new house already generated somewhere closer to the screen. Yeah. Okay, no errors, but this is funny. So this is half the screen here, right? So I don't want to allow this random value to be between 0 and 1. I want it to be between 0.5 and 1. So I can say here 0.5 plus half of the random value. And now this should be something more nice. Now you expect the houses in the bottom part of the screen to be larger, right? Because they are closer to us in perspective. So this size here that we are using for the house, should also depend on what is the y coordinate. And we could, for example, put y here and see what happens. Okay, so y is way too much. It's not gonna be a nice nice value here. So let's make it smaller. I'm going to say let size is equal to y, maybe divided by 2. So now I expect that the houses in the front are going to be larger and the houses in the back are going to be smaller. It is kind of happening like that. I would like this difference to be bigger actually. Anybody has any idea how to make the houses that the more that the house is going to be upwards, the smaller its apparent size is going to get, but more significant, a more significant decrease the more you go up. Any ideas? Well, mhm. Yeah, so okay, remember that our y is between 0 and 1, but now I'm making it between 0.5 and 1. So if you say 100, I expect that you mean 100%. It's just fine, but just so that it's clear. So all of the y values are going to be here, and I want big sizes in the bottom and small sizes in the back. And it is happening now. You can see that this house is smaller than this house, but it's not that much smaller. So I want it to become smaller. The ones in the front are okay, but I want the size to shrink more powerful as you go towards the back somehow. This has to do with perspective and understanding a little bit how 3D works, but can you try to answer again? Well, I don't know if that will affect. So height of the green area is 0.5, right? I mean, it will do something, but let's see what it will do. I basically scaled it in half. So I said that the previous values of the houses, when I used this without multiplying by 0.2, all of those houses, whatever it works like this now, become half the size if I do this modification now. Um, so Pythagoras is for distance between 2 points, right? But Yeah, yeah, okay. Well, not sine necessarily, but Pythagoras does have squaring involved. Let's try that. What happens if we say here, if we multiply this value by itself, what would happen in this case? So basically, it means that the bigger the y's, even bigger y's are expected to happen, but smaller y's mean very, very small y's. Now, this depends a little bit because, okay, maybe I don't need to divide it by 2 here. Okay, we are also in the scale of 0 to 1, so multiplying two values here actually shrinks it. Okay, this is a little bit of math involved, but let's see what happens now. Okay, seems like my trial and error is not proper. Hmm. Maybe the idea was good, but I should just multiply this y. I mean, not divide it by 2 again because it's basically dividing by 4 and it becomes too small. I just want the houses in the back to look much smaller than the houses in the front. So if you think about quadratic function and how it works, it increases quicker. So when you multiply something, mm, but I don't know, is this working? What happens if I multiply again here? So I force uh, even steeper angle there. So yeah, let's see what happens. I suspect that this is gonna work somehow quite nicely. I'm also gonna make the speed much faster for future testing. This is way too slow. I would like to see, okay, so this looks something I am happy with. Basically, what happens is that the size, it does depend on the y angle, but now it's really, really emphasizing large values of y because it's multiplying again and again and again. So the closer you are to the screen bottom, which is the maximum values of y, closer to 1, multiplying these by 2 or by not multiplying by 2, raising them to the second or the third power, like having quadratic or cubic functions here, are going to have a more significant effect of the scaling. But the ones that are up close to the horizon, multiplying those values by themselves aren't as significant. So I'm not using a linear scaling here anymore. I'm using a polynomial scaling of the values. And I think that just raising to the second power is going to do the trick. So you may want to see what this kind of function looks like plotting it on paper or something like that. But you can see that the effect is somehow what I intend to have here. Okay, more houses. I want the house to appear with probability of because I want to debug really what a dense scene looks like. So I'm going to increase here this probability. Okay, let's increase a bit more. Notice any problems? Yeah, it kind of looks like floating houses, right? So there is an effect of this kind of floating house if a house generates like this one. Let's see. If a small house is displayed on top of a bigger house, it looks wrong, right? So you expect that the small houses, the ones that are also in the back, are gonna be drawn first. And then the houses that are bigger are gonna cover them. But when you see some kind of small house being on top of a bigger house, you get this kind of weird effect. So it's now messing up with our 3D perspective here. This is not 3D. This is just me playing with the canvas, trying to learn drawing methods and animation methods, and also teaching a little bit of tricks there. So how can we solve this issue that like this one here was really drawn on top of the other ones? I want to draw always bigger houses last. Very good. Very good. Yes, exactly. Now, a little bit talking about memory consumption. I'm having now 14 houses here, right? You can see from my debugging. Now it's 37. Now it's 54. These houses are always going east. West, sorry. Yes, west. They are going west. They are going to Sweden. And then they are going to Norway. And then, I don't know, ocean and whatever. I don't need to keep in memory 117 houses. So this will crash my computer no matter how performant, how powerful it is. So if something is not needed in the screen, you don't need to bother with it anymore. And we can remove it. So before we do the sorting, let's do this, removing houses that appear off screen. Otherwise, if I sort all of these cumulated houses in memory, it's going to be a very slow sorting, right? So I'm also teaching you a little bit about making this efficient, not just visually nice. So I have my houses here moving to the left. If what this method does is it removes the element at index I, and it only removes one element. Now, a small issue here is that when you remove an element from the array, the next element takes its place. So if I want that next element to also be processed in a way that this X location for it's going to change, I need to backtrack here one index so that the next step it's gonna be at the same index, but the new element is there in that location. If I don't do this, screen may fidget a little bit, or maybe one house will, for one brief moment, stay in the same location there. It's not a big deal, but it's something that you should consider there. Now, when I'm debugging now my houses, I have 15 houses here, 15 houses here, 10 houses here, 12 houses here. So the number goes up and down. It depends how many houses are on the screen, but I'm not gonna get memory overflow anymore in this way because I forgot about all the houses that escaped on the left side of the screen. Yes. Very good point. Thank you. Yeah, I didn't even note this. Thanks. So I don't want them to disappear here on the immediately when it's 0, because that makes them disappear when the center of the house, reaches 0. So basically, I still see half of the house and it's gone. So I want actually the houses to disappear after half the size of the house has passed from this 0, 0. Of course, I could also put a big value here, a bigger value here, like minus 0.5, so half the canvas. But I can actually use the size of the house half the size of the house in the negative direction. So now I think that this is going to fix the problem. Let's see. There is no more blinking, but what happens to my number of houses? Doesn't seem to work. Oh, I'm sorry, I made some mistake. The object property is scale, not size. We could have figured this out somehow by debugging, but I just figured out by looking at the code. It probably, JavaScript is really permissive, and it probably would have looked there, saw some undefined value, and then asks, is this value less than undefined, which is something makes absolutely no sense, but in JavaScript seems this just never happened. So let's see now. Okay, no blinking, so the houses don't disappear anymore too early. And the size of this array still fluctuates. So because it goes up and down like 12, 10, 11, that indicates to me that houses don't just grow. They also disappear sometimes. Okay, we can also consider this pushing the house not to be necessarily off screen, because that's an object that you have to process longer. Like now all of them are appearing half a screen away, but it's enough to make them appear at the 100% point. If I put 100% point here, similar problem as before, but opposite. The house blinks into existence exactly halfway after it has passed. So from this 1%, I can add, yeah, I can use size now because it's this attribute here divided by 2 or multiplied by 0.5. It's the same thing. And now the houses come into existence just barely before reaching the screen. So it looks very, very nice, and I don't have to process a house moving for nothing. So it's very good point. Thank you for noting that. And now we go to the previous comment. Maybe Julian or Julian, I'm not sure who said it, but sorting was suggested. And yes, if we sort so that the smaller houses are first, then they are going to be drawn first, and the bigger houses are going to cover the small ones, and we don't get this weird floating small house effect. So let's sort this, and I'm going to teach you two ways. Let's say, who knows bubble sort? Okay, this is, I don't even know what I'm typing. I think I'm typing selection sort. So if one house is not as I expected, so I expected the bigger ones to be at the end, and these J values are in the later part. If houses of I dot scale is bigger than houses of J dot scale, I'm gonna swap them. I think this should work. Let's see. So now I'm hoping that big houses in the front, small houses in the back, and no weird floating effect. If I and it seems to work, if I change here from greater than to less than, it should actually produce a bunch of these floating houses because everything is backwards. The bigger ones are first and the smaller ones are second. Now, this is, I'm pretty sure, some sort, but I actually don't remember the names of this sorting algorithm. Selection sort is the one where you get the minimum value at each step and put it in the next index. So I think that this one, yeah, at each step of y, I think after this for loop finishes, it's gonna guarantee that the smallest one is at index I. But of course, there are many implementations and so on. This is not also the most efficient way of doing it. There are better algorithms, and JavaScript actually has built-in sort function, and I'm gonna show you that as well. Okay, just a second, some messages. Oh yes, Berat mentioning the native sort function. So yes, we could do that. I think it's something like this. And I have to specify that I want the property of the house that will be sorted on to be the scale in this case. So I just have to give it a callback function. How do we make the comparison? I think something like this is gonna work, and I don't need my stupid sorting function here. But again, because the number of elements, oh, okay. What did I do wrong? Well, not objects. Yeah, I thought that I named them objects, and yeah. Yeah, so the array needs to be sorted, and I need to give it the comparison function there. Yeah, seems to work. Of course, I could do the same kind of trick for the movement speed. Like the size is now a quadratic function. If I change also the movement speed with a 2-degree polynomial, then I'm probably going to get a nicer movement. Let's see. So here, instead of the speed being multiplied So now this location y is the same as y value here. So let's see what happens if we raise it to the second power. So same as multiplying it by itself, but now I'm using the POW method from the math library. So I'm now hoping that houses in the front are gonna move faster, like significantly faster than the houses in the back. Okay, it somehow works. Let's see if we can get it even bigger difference in these speeds. Yeah, I think you can see this effect. So these houses in the back now, they are going quite slow compared to these ones in the front. So basically, raising it even higher is going to make this difference even more significant. So now you can see that already here the houses are quite slow already, but I kind of liked how it looks like here. Now there are equations definitely for making this be realistic, but I'm not going to study these. I don't know them myself, and I just want something that kind of looks like what I promised that we generate today. Okay, let's quickly add the trees also here. And maybe do we study a little bit more? Do we study a little bit more object-oriented programming? Let's see. So I'm gonna do the same thing for the tree. The tree is still now this draw tree function, but I need to make it a class. And constructor is actually identical to the one from the house, but I don't have any angles there. So I actually think we don't have even properties. This properties field style. Okay, this was never used. The field style here, this is just the color of the trunk, and I think we could say brown here. We never made this as a parameter. So yeah, we just need the location and the size of the tree, and give it also the draw method. And this is gonna have the context again, and I just copy whatever is here there. And I don't need this function anymore. The only thing I need to worry about is this keyword. So I need to add it here and to the scale. And this objects, actually, what I misspelled earlier, I have some notes here on the right that what I want to do next, and this sorting function that I showed you, actually, I planned to have it a bit later, so I copied differently the function, the object name. I want to group together the houses and the trees in an objects array. So no matter what we will see there, it's going to be either a house or a tree, but my code is going to treat them as an object that appears on the screen. So I'm renaming now the houses object with the houses array with the name objects, and I'm renaming it everywhere. So let's see. And then I'm going to sometimes generate random trees there, not just not just houses. And I think the scene is going to look a bit nicer. And this is something we don't need anymore. I kept it before because I wanted some backup code. I never needed it. Okay, so when I'm generating new houses here, maybe I want to generate a tree with another probability, like a tree probability. Let's say half and half. There will be half trees and half houses. So if this tree probability is less than half, I'm going to, yeah. Yeah, okay. It could be like that, but you could also interpret it as probability to generate some object. And then what is this object? Half the time it's going to be a tree, half the time it's going to be a house. So what you are saying is correct. I could design it that way, but I think that this probably will work as well. Let's see how it looks like. If it's not good, then we can. I think, yeah, I removed the properties from there. Let's see if it works. Well, yeah, so the number of objects stays the same as previously. We still have this 30% probability to generate something. But now half of the what would have been houses previously are replaced by trees. So this is something that I wanted to achieve more or less. Okay, you can ask things or suggest anything basically. I think that well, I would like to also show something else that we could do. Maybe we learn a little bit about this class inheritance. I don't know if it makes any sense to practice here, but basically, I don't know if the word object is reserved in JavaScript, but let's see. So we could say that, nah, it's too much. Let's just leave it like this. But basically, the scaling of the house and the tree is the same. The higher it is, the smaller it should get, and vice versa. And the movement is the same. Houses and trees have the same speed, 0. But relative to the train, they do have the same speed as the train. And the way that the perspective works is the same for the house and the tree. So in principle, moving all these objects could be done, could be encapsulated in an object class. But I think that time is running out and I'm not gonna do that anymore. Let's see, is our objects. So now our objects are house, house, tree, house, house, tree, house. Yeah, funny. So how many objects do we have? We have 24, 25, 23. So they are changing, entering the scene, leaving the scene. Okay, one thing that we could check to see how it looks like is what would happen if I don't scale this to the full screen size, but maybe I scale it to half the screen size. So just to practice a little bit more this scale function and see if we can learn a bit more. So what do you see now, basically? Can somebody explain what is happening here? Anybody? So our canvas was scaled not to the full screen size of 1000 by 1000 pixels, but to half of that. And what is happening here on the right side? I will give you a hint. Wait, somebody is. It doesn't draw the scene on top of the white part, so it leaves the trace. Yes, it doesn't draw. Actually, it does draw the scene everywhere, but the background is only drawn uh, between 0. So it starts at 0, it has a width of 1, the sky part. The green part also has a width of 1. So our background is basically only drawn on the 0, 1 normalized scale. And when you draw the background, it covers the previous houses, no matter what was there in the screen. But this background is not drawn outside of this area of interest, the place where we are interested to see things. So if I would make this background extend to have a width of 2, basically 200%, then I won't see this effect anymore, because now I'm drawing my background over the houses that are generating there in the beginning each time. But I prefer to keep it like this because it serves as educational purpose. So every time I'm drawing on the canvas, the pixels stay there. If I don't remove them, I can mask them with the next time I draw the background, for example. So yeah, good. So that's exactly uh, what what we are doing here. How could I move so that I see the houses on the left side of the canvas? Basically, I would like to see them also when they truly disappear from memory. Could I do this in one line of code? Anybody? Yeah. How much? Notice that this is after scaling. Well, like that maybe. Let's see. Okay, so something worked. And you can actually notice that the houses that are passing this border are going to be deleted instantly when they are reaching the side of the screen. What is remained here is their final pixel value still stays there, but actually these houses that are here, they are gone. These are just pixels. It's not anymore a house in memory, but it's kind of like its footprint is still there. You can see it like this. Of course, if my scaling and translation here are as before, I actually see the meaningful scene that I was planning to do, and none of these things that are outside the screen area are going to be disturbing me. And I'm not sure if you can see the difference, but I actually can if I toggle to request animation frame here. This is somehow a very rough animation, and sometimes the objects are moving a little faster, a little slower. Do try to see how it is different if this request animation frame here is enabled. And you remove the interval. I don't know if you can see a difference since I'm recording, and it's also quite hard on my processor, but and it's faster, but of course you can play with the speed as much as you want. Now we have it here as a global parameter, so I could make it go slower if I want very easily, or I could make it go even much faster. Or you can make it change speeds. I don't know. Somebody said sine function previously. So how about in our animated value, we're going to make our speed equal to so let's have a frame count to keep track of which frame we are at. Start at 0. And here, well, probably not the place where I should increase it, but I'm going to increase the frame count. And now my speed is going to change according to the sine function. So the sine function actually, oh, this is not going to work, but something will work. First of all, it's going to be too fast. So let's make this a bit slower. But the thing is, sine is a function that goes up and down. And when it goes up, it goes from 0 to 1, and then it goes to -1. So -1 is actually going to make my houses move in the backwards direction. But I don't think this is going to work. Okay, speed is a constant value here. I need to change this. Oh, and frame count. Okay, something is weird. Yeah, let's make it. The frame count is going way too quickly. So sine oscillates between 0 and 2 pi. 2 pi is 6 something. So that's why it's so quick here. But if you take a fraction of the frame count, then you're gonna see a bit more of this kind of movement. But see this weird effect that more and more houses are coming from the right. So it's kind of like a magic trick. Of course, I could keep the speed be always a positive value. So I could take the absolute value of this speed here, and now I get the sine function fluctuate from 0 to 1 to 0, and instead of going -1, it's gonna jump up again. But the jump, it's gonna be kind of like a bounce. So you see the house is moving, getting faster and then slower, and then faster and then slower. So if you don't want the slow to be a complete stop, you could consider adding here a small value. I don't know. This is more about mathematics and understanding how these go. Maybe too small, but they could be things that you find useful um, in your code, in your project work. So I hope this was clear, and I think we are out of time. So any more questions? So 200 actually makes it um, even slower. So think about this as a number of frames per second. So if you put here, I didn't put anything. If I put here 1000, then now my animation is going to go every 1 second. So this is not a problem. Maybe you want your animation to be like this for whatever reason. If you put 10, then this is gonna try to go 100 times per second. But if you debug and you see how many times are going per second, it's not gonna be true because your processor is most likely limited. Like if I say here 1, this should be in principle every 1,000 times per second, but it looks very similar to previous case. This doesn't really isn't really making the point of why I'm suggesting this request animation frame. The reason why I'm suggesting the request animation frame is that this set interval not only cannot accomplish anything that you give it, like if you give a very small value and expect it to process a lot, if your processor just can't handle it, it's gonna be slower and it's gonna be maximum processor used there. But same thing happens for the request animation frame. I mean, it's gonna try to give you frames as quickly as it can. The difference is that request animation frame tries to space them better. So in the set interval method, it could be that once it's waiting 5, once it's waiting 100, once it's waiting 10, depending on how busy your processor is or how complicated the scene is. Depending on how complicated the scene is, it's gonna dictate also your processor's behavior and so on. The thing is, the request animation frame method tries to keep those values as evenly spaced as possible, so you don't get fluctuations. Otherwise, your movement could be something like this, like goes small in the beginning and then has a weird jump in the middle and so on. If you do play with this code on your computer and you're not streaming video and recording video and all kind of stuff at the same time, you will see some difference in quality of the output. Sure. Any more questions? Mhm. It tries, yeah. Mhm. Wow. Yeah, well, it's not very complex page. All right. So if you do have a very powerful processor, then maybe using this set interval, you could reach better performance. I mean, more frames per second than the 60 frames per second that request animation frame tries to get. Um, then again, the reason why request animation frame uses 60 frames per second is because it's even more than what people need in practice. So people have been very happy with 30 frames per second for a very long time now, and more recently 60 frames per second are more and more common, and I would say similar these days as the 30 frames per second. But more than that, I mean, human eye can't really see more than these values, and it wouldn't make a big difference. But I think good point. So yeah, if the request animation frame method is trying that 60 frames per second, then you could go beyond that with interval or timeout methods. For simple scenes like this one, I mean, this may look kind of complicated, but it's not that. They are just some polygons being drawn there. So of course, this could be made even faster because now my the size of the canvas is 1000, and we could lower the canvas size and get even uh, faster processing. But any more questions? Is there anything on the chat? Yeah, exactly. So it could be that the screen is glitching in my recording, but do try the code when I publish it, or if you code it along, then even better. Yeah, you're welcome. So I think see you on Friday at the exercises.